Hello all. This is our entry for building the next gen agentic app with GraphRag and NVIDIA QGraph challenge. Our app named is ArangoMedica, ArangoDB-powered medical AI, targeted for healthcare section. So what problem we are trying to solve? ArangoDB-powered AI agent is solving a graph-based medical intelligence problem where patients' diseases, symptoms, and treatments are interconnected. Our AI can analyze this relationship to provide insights like finding the most critical symptom for a disease, example hypertension, asthma, predicting potential diseases for a patient based on symptoms, finding treatments that work best for certain diseases, identifying patients at high risk based on co-occurring symptoms, detecting hidden patterns in medical data using graph analysis. So why we used synthetic data? Because it can simulate real world medical graphs, test AI algorithm at scale, 3 million plus relationship, perfect for AI model training, develop a working prototype that can later be integrated with medical data sets. We persisted the data with a batch size of 1000 into the graph-based ArangoDB. Then we created the graph instance for that. We had around 9,409 nodes and 1,97,116 edges. So let's take a look at our database first. We see this is the instance of the database that we have. It's a subgraph that you see over here, 250 nodes and 249 edges. So if you go to the collection, you have the name medical underscore node and medical node to medical node itself, document and edges. So let's go back to our slide. So after persisting the data, some simple equal to validate graph parsing was successful. It's there in the Jupyter notebook, you can check for it. So it's the you're showing the nodes as well as the edges of it, and to check the nodes as well as sample edges that are there. So this is a small visualization of the entire database that's being created, or data set that we have. It's a visualization of the subgraph and the relationship that's there within the data itself. And meet our AI agent. So when we put in a query, what exactly it does, the AI agent reads our question, breaks it into smaller tasks, fetches data from database, runs a smart algorithm to find the answer, explain the result in simple terms. So why it is powerful? It automates complex and graph analysis, no need for human expert. It works dynamically, it figures out the best approach based on our question. It's explainable, the AI tells you why the answer makes sense. Our solution consists of 5 different tools working together as an AI agentic approach. That's simple data retrieval for ArangoDB queries. We have graph analysis, that's for network X algorithm. Then we have hybrid query approach combining database and graph analysis, SQL filtering and network analysis. For that we are extracting a subgraph, that's another tool, and visualization tool. So hybrid query mode we focused along because it consists of lot of steps. So what exactly it does is that ArangoDB for structured graph database queries, network X for graph analytics, uses the GPT-4o for reasoning and query interpretation. So let's take a look at demo. Our demo is divided into 2 parts. One is using the OpenAI agentic integration with LangChain and LangGraph, and the other is the Microsoft's AutoGen framework. We have included both of them. So let's see the demo in action itself. So here is the first notebook where we have the data that's being provided. So let's run through one of the queries. It's this is the query, who is the most important popular person in the graph, explain why. So if you run through the query itself, you'll see like it goes through creating the network X code, gets the information, and it will pull up all the data that's there. So intelligently it pulls up all the information using the logic for AI agent and gives us the result itself. Now let's take a look at equal based query. Now this particular query that you see, like, translate this natural language query into equal, find all diseases treated by drug aspirin. So if we run through this particular query itself, it goes inside Arango graph QHN, it gets the result, and finally it pulls up the result for us. Now let's take a look at one of the hybrid queries that we have. So identify the most influential symptom among patient diagnosed with diabetes using PageRank analysis. If you run through this, it's a hybrid query. You'll see like it gets into an Arango graph QA chain. It goes to the details of it. Equal query generates the sum of the things that are needed, and it passes on to the next node to generate the network X code, and finally it gets the result for us. Okay, so the result is being put over here. Now let's take a look at one of the other queries where we are looking at visualization. So visualize only the betweenness values for subgraph of disease and treatments. So if we run through this query itself, you'll see like the legends are being shown for different subgraphs where we have low centrality, medium centrality, and high centrality. So it is showing the entire result for it. It's a subgraph that you are able to see, and the nodes are being shown over here. Okay, similarly, if we pass in some of the information in Gradio also, you can see for a text analysis. Okay, so as we have passed in the query, identify the most influential drugs for disease asthma for PageRank analysis, and click on submit. The query will run through the entire information. Because it's a hybrid query, it takes a little bit of time. It will come up with the results itself. And after that, you will see we are moving into the AutoGen mode where we are giving in the information for how the AutoGen based framework is working. So that's the output that has already come in. So let's take a look at AutoGen based application. We are focusing most importantly on the part where we are initializing the AutoGen. So we are importing AutoGen over here. We have called put in all the tools similar to the tools that we have created. This is a system based prompt. We are into the assistant agent mode for AutoGen. So let's take a look at one of the queries itself. So if we put in this query, you see like it goes directly to the text to next NX algorithm tool, and finally it formulates the answer for us. So this is how we have built in. We have put in all the information using two AI based agents. One is using the AI agent using LangChain and LangGraph. The second is AutoGen. So let's just move into the slide itself. Now we have put in the demo. You have seen through it. What's next for our application? So this particular application was useful because ArangoMedica helps uncover hidden relationship between symptoms, diseases, treatments, and patients using graph-based AI reasoning. So we plan to take it forward for predictive healthcare AI, enabling early disease detection, risk assessment, and personalized treatment recommendation. The most challenging part was the balancing the real time querying and the graph analytics while ensuring AI makes the right execution choices dynamically. We like the native based graph traversal database support, multimodal approach for ArangoDB, and fast SQL execution, making it perfect for our AI driven medical knowledge discovery. Thank you.